In this video, I'd like to introduce the homework 1, which is about implementing a parallel web server. So in the homework directory, you can run the server using this cargo run hello server. So you need to implement a few components of the server in order to get it done. But this is the completed homework, and this is the expected outcome of your homework 1. So when you start the server, it prints some log, and when you go to the web browser and then go to the address localhost colon 7878, then it will print an error message. But if you're going to go to, for example, Alice here, then it will wait for a few seconds, and then after computing an expensive computation, it will return a page. But you can see that there is a delay. There is a delay between the request and response, so because there is an expensive computation. But the result is now cached. So if you refresh, then it will return the page immediately for Alice. But if now it is asking a page for Bob, it will again compute an expensive computation, and it waits for a few seconds. But now the result is cached, so you can refresh it and the result will be immediately returned. So this is basically such a web server, and this is basically printing some log. The log is not that important, but at the end of the execution, you may want to exit the web server by pressing Ctrl+C. Then it should it should write down some statistics that says there is a widget. It is a widget count basically. The Bob page is visited 5 times, and an error page is visited 4 times, and Alice page is visited 7 times. So basically, when Ctrl+C is pressed, you need to print out the statistics of the accesses. So this is the specification of the web server, and in order to do so, we already provided a significant amount of skeleton code. And let's look at the code a little bit. And this is the top level file that is actually implementing the server here. And you are going to first, in this main function, you are creating a thread pool. The thread pool is basically a set of threads. And if you want to execute the job, then you're going to throw the job to the thread pool. And the thread pool will automatically select the thread and execute the job. And if the job is finished, the thread is returned to the thread pool so that it can be used to execute another job. And here we are creating a thread pool of size 7. Now we are creating some channels that is needed to transfer a job to the next thread. And also we are creating a TCP listener to that address of localhost colon 7878. And this is marked as cancelable in a way that if this TCP listener is cancelled, then even though there is a remaining connections, it is going to be dropped basically. Okay, and when Ctrl+C is pressed, it is going to order to cancel the listener. That is basically what's going on behind when you press Ctrl+C. When you press Ctrl+C, the TCP listener is cancelled, and as a result, every resource is cleaned up from there. And there's a listener. The listener is a thread, and it is going to listen to the TCP listener that is created here. And for each connection, incoming connection, it is going to execute the job using the pool, the thread pool that is created at the beginning of the execution. And it is doing this. It is first creating a handler here and actually handle the connection here and get the report. And you're going to send the report to the what is called a reporter basically, and there's a channel between a listener and a reporter. I mean the job handler and the reporter, and this is the handle for the channel. You're going to send from a handler. Your handler sends a report to the reporter. And there's a reporter, as I said, it is also a thread, and it is collecting the statistics. And when there's no longer report, that means that the server is terminated, then it is going to calculate the statistics, and then the statistic goes to the main thread, and main thread receives the statistics and print out. That is basically what's going on in this code. There are many threads, many kinds of threads, listeners and workers and reporter and the main thread, and they are collaborating to deliver concurrency in handling the web server. So because there are parallel resources, parallel threads, it is truly parallel web server. And these threads, for example, listener threads and worker threads and reporter and the main threads are communicating with each other using channels. And the channel is imported from the crossbeam crate. There's unbounded channels and bounded channels, and they are used appropriately. And this is already provided. It is in the skeleton code, so you don't need to implement the server on your own. But you need to implement some components of the server. Specifically, I want you to implement the thread pool and the cancelable TCP handler and the cache that is used for storing the result of expensive computation during the handler. So let me show you the skeleton code. So let me begin with the cache. The cache is basically a key value store, and it only provides one function: get or insert if. So you're basically querying this cache key value store with a key here, and you have to implement it in such a way that if you already have the value for the key should be immediately returned. Otherwise, you execute this function and add the result of the function to the cache and then return the result of the function. This function may be very expensive. That's the reason why it is cached. In particular, it can spend seconds. So it is beneficial to store this the value of the result of this computation in the cache, basically. Okay, so far so good. And you need to also implement the TCP listener that is cancelable. So there is already a TCP listener that is implemented in the standard library of Rust, and you need to use it inside your cancelable TCP listener. And it provides the API, the same API with the underlying TCP listener. But in addition to that, you need to implement cancel. Cancel is a function that cancels the TCP listener. So the bind function is simple. It is binding to an address as the underlying TCP listener. And what is interesting here is that is canceled is initialized with the false. And here you need to implement the cancel function. Cancel is basically setting up the isCancel variable. And in order to do so, you need to call the API of this atomic bool. And as I said in this code here, you can just write it, or you can just call the store function with release ordering. But it's not the end of the story. After you set up the cancel bit here, you need to somehow notify the TCP listener that you are quitting, you are canceling, you are exiting. And you need to do such a thing. You need to basically wake up the TCP listener that may be blocked, and you need to implement that in this cancel function. Okay, that is the second homework, and and furthermore, in the next function, you need to implement the next function that is basically returning the next TCP stream, the next connection. So what is particularly interesting about this is that if the is cancelled is true, you need to just return none, which means that your stream is ended. There's no longer connection because it is cancelled. So if it is not the case, you just return the next stream of the underlying TCP listener. This is basically what we want you to do. And again, I said that here you need to set is cancelled with what is called the release ordering, and here you need to insert, you need to write you need to read from this is cancelled using acquire ordering. So the precise meaning of this release acquire will be discussed in later sessions of this class, but just memorize and use release acquire at this stage. And the last thing you should implement is thread pool. Thread pool is, as I said, a set of thread, and a job can be executed inside the thread pool. And the API is like this. You can create the thread pool, and you can execute the job, and you can wait for all the executing thread jobs to be finished. So that's basically the meaning of join here. And you need to implement this using some channels again. So there is a channel between the thread pool and the workers. And if you are executing a job, then you are going to insert the job into the channel. And each worker is trying to get a job from the channel and then execute it. Basically, that is the high-level idea of how to implement this thread pool. And in order to implement join, there will be this struct will be used, which is basically tracking the number of ongoing jobs. And if the number of ongoing jobs is 0, then the join can return immediately. So you need to implement the logic inside these functions. Fortunately, a lot of functions is already implemented in the Rust book. The final project is also about implementing thread pool, and you can just copy and paste many of the code from there. Okay, and if you implement the 3 components, cache and TCP and thread pool, then all the other components are already prepared, and you can run the server, the demo I already presented at the beginning of this video. So, and doing that is homework 1.